Voyager is still defying the odds at the furthest reaches of the solar system some 50 years after its launch. Nobody could have foreseen that the program would go on to hold the record for the longest run in NASA history. Up to this point, the probe's voyage has been uninterrupted. Data indicates that Voyager 1 has contacted an unidentified extraterrestrial object. Let's examine this bizarre experience in more detail and see how Voyager 1 just made contact with a highly advanced object in space. The Voyager project, the Voyager program, comprises the Voyager 1 and Voyager 2 robotic interstellar probes, the longest space mission in human history. They were launched back in 1977. Their journey has taken them to the outer edges of the solar system, a feat no other spacecraft has achieved. Voyager 2 was the first spacecraft to leave Earth, but due to the path it traveled through the stars, it would finish second in the race to the heliosphere. The mission's objective was to investigate the solar system's outer region and learn more about the outer planets and their moons. The Voyager spacecrafts are presently investigating the heliosphere's outer limit in interstellar space. As a result of their success, the mission has been extended 3 times as they continue to transmit useful scientific data. Voyager 1 officially became the first artificial object to leave the solar system and go to another star system on August 25, 2012. The probe is presently ascending 35 degrees above the ecliptic plane at a speed of around 320 miles per year, or roughly 10 miles per second. Alien object, the Voyager probe's age may finally be catching up with them. Even if they are still sending back data to Earth, the fact that probes are still operational after several decades of degradation in orbit, however, is something NASA anticipates. Voyager 1 may have made touch with an unidentified object, according to the data it has received, which has scientists curious. This might be anything from gas pockets to space junk, or it could be something far more complex. There is no way to tell for sure due to the distorted data, but it is horrifying to consider that an object that is moving towards our solar system made touch with the probe. To make matters worse, due to the great distance, communication with the craft now requires a whole day. Due to this, it has become much more difficult to analyze this strange data and attempt to repair the probe. Initial diagnosis reveals that the malfunctioning AACS may be responsible for these invalid messages, as the data could have been corrupted before it reached home. But there is no way to know how much of it is invalid. The puzzling part is also that no one at NASA can explain why the probe began performing weirdly, because of the AACS wasn't failing before the strange behavior began. Since then, NASA has reoriented the ship and discovered that it is still fully functional. This has led to the speculation that the probe could have made touch with something and changed course as a result. The only other possibility is that over 50 years of immaculate operation, the Voyager finally encountered a malfunction. There is no doubt that something strange happened to the probe that day, despite the difficulty of explaining these occurrences, yet we may never be certain of what it was. There is no doubt that if the probe was engaged by unseen entities, Voyager 2 will soon travel through the same region, allowing us to contact them again. Discoveries, the favorable alignment of Jupiter, Saturn, Uranus, and Neptune, which only happens once every 175 years, was scheduled to occur in the late 1970s and was utilized by the Voyager mission. The probes employed gravitational aids, or changing the route and speed of a spaceship by taking advantage of the gravitational pull of a planet or other celestial objects, to save fuel and save costs. It is possible to either accelerate, slow down, or reroute a spaceship using gravitational support. While Voyager 2 was launched first on August 20, 1977, Voyager 1 was launched on September 5, 1977, on a faster and shorter trajectory. The probes were designed to perform up-close analysis of Jupiter, Saturn, and their biggest moons. On March 5, 1979, Voyager 1 was 172,368 miles from Jupiter as it made its closest approach to the planet. The probes were able to monitor Jupiter's cloud formations as well as its wind and storm systems, and they learned about Io's volcanic activity. It was the first time that active volcanoes had been seen on another body in the solar system. The volcano's plumes rise more than 190 miles above the ground. The second largest planet in the solar system, Saturn, completes one orbit of the Sun in 29.5 Earth years. The planet is known to have a sophisticated ring system with at least 17 moons. In addition, it was found that hydrogen made up the remaining 7% of Saturn's upper atmosphere. Titan, Saturn's largest moon, was also studied. With a diameter of 3,200 miles, Titan is the second largest moon in the solar system. It is around the same size as Mars as a result. The discovery of a magnetic field around Uranus and 10 of its moons, as well as the finding of 3 rings and 6 undiscovered moons of Neptune, were among the most significant discoveries. Also, Voyager 1 and 2 delivered us a ton of up-close images of the giant planets. The pale blue dot photographed by Voyager 1 in 1990 is one of them. This well-known image shows the Earth from a distance of around 3.7 billion miles. In the vastness of space, Earth appears as a very little blue dot. It was decided to extend the Voyager's program mission and rename it the Voyager Interstellar Mission because the major goal of the program was accomplished in August 1989 when Voyager 2 sailed within 3,000 miles of Neptune. The objective was to continue exploring the solar system past the outer planets and, if at all possible, past its boundaries, or what is known as the heliopause boundary. It may be described as the boundary at which the interstellar medium stops the solar wind coming from the Sun. After crossing the heliopause, a spacecraft will be able to study interstellar fields, particles, and waves that are unaffected by the solar wind, giving researchers priceless information. One of the major open issues in space physics have been the location of the heliopause. Researchers have theorized that the heliopause is located between 90 and 120 astronomical units from the Sun, based on their analysis of the radio waves. As of right now, the probes are still returning critical information to Earth. At the moment, they focus mostly on ultraviolet sources among the stars and investigate where the impact of the Sun ends and interstellar space begins. Astronautical investigation Voyager 1 recently made news when it detected the interstellar space itself, a faint plasma hum that scientists have likened to light rain. This find was made in a remote region of our solar system, some 14 billion miles distant. Voyager 1's mission has included plasma from the beginning. The spacecraft found lightning strikes in Jupiter's atmosphere and investigated how the solar wind changed as it moved further from the Sun. Since 2012, researchers have focused the spacecraft's equipment on a region of far-off space that has never been probed before. The plasma around the Sun was measured by Voyager 1 as it drifted away from it. Most of the time, this region of the interstellar medium is calm. Because of the limited frequency bandwidth, it is exceedingly feeble and monotonous. Yet, the solar wind pushes back every few years. These occurrences are detected by Voyager 1 as shock waves. Scientists first believed that Voyager 1 could only estimate the density of the plasma outside using those shocks. Nevertheless, now that they have detected this unusual hum, scientists can monitor the interstellar medium in between shocks, which will allow them to learn much more about a still mostly unexplored region of space. The interstellar medium has a lot more low-level activity than previously assumed, according to scientists. This finding demonstrates that measuring interstellar plasma does not need a chance solar outburst. Whatever the Sun may be doing, Voyager is returning incredibly crucial information on this plasma. It monitors changes in the environment and describes the densities it passes through. If you like this video, you may also be interested in this one, which talks about NASA's launch of a spacecraft that can travel faster than light. Do you believe the Voyager mission can last another 10 years? Then please post your comments in the comments box below.